Hello students, and welcome to my channel once again. So in continuation of the series of the linear equations in two variables, so already we have discussed in the beginning that what is the meaning of linear equations in two variables, and then in the next video we discussed about one of the method of solving the linear equations in two variables, that is the substitution method. Now before we start we learn the next two methods, that is the graphical method and the elimination method. So first we will discuss the consistency, how we can find out consistency of the linear equations in two variables, whether the solution is there or not, whether the pair of linear equation is consistent or inconsistent. So before solving by any of the method, the three methods which you are going to learn, first we will find out that whether the solution is there or not, whether the pair of linear equation is consistent or they are inconsistent. So that is a very important part in this. So first of all, we will write the general form of the linear equations in two variables. And what is that, the general form? That is a1x plus b1y plus c1 equals to 0, and the second one is a2x plus b2y plus c2 is equals to 0. So already that substitution method, so you have done, so you know what is the meaning of this a1 b1 c1 or a2 b2 c2. These are the numerical coefficients. Like in the first equation, you know, this is the first equation and this is the second equation. A pair of linear equations always you will get, because with one equation in two variables you cannot solve it by any of the method. So whatever the numerical coefficient of x, that we call it as a1, what is the numerical coefficient of y, that is b1, and the constant term in the equation, that is c1. Same in the second equation, the numerical coefficient of x is a2, the numerical coefficient of y is b2, and the constant term is c2. Like if we compare, and if I'll write here two equations like 2x plus 3y plus 6 is equals to 0, and another is say 5x minus 2y plus 10 equals to 0. So if we compare here, so very easily you can tell, if I'll ask you what is the a1 here, so 2 is the a1. What is b1? So you can compare, b1 is 3 and c1 is 6. Same way if I'll compare with the second equation, so a2 that is 5, b2 that is minus 2, negative 2, so sign also is very important, and c2, the second equation, the constant term, that is 10. So I hope you understood the general form of the equation, what is the meaning of a1 b1 c1 and a2 b2 c2, because using these a1 b1 c1 and a2 b2 c2 very easily we can find out, because in 10th class in CBSE board you will get the questions based on this, sometimes in 2-mark questions, sometimes in 3 or 4-mark questions. So in 2-mark or sometimes in MCQs also they ask this, that check whether the pair of linear equation is consistent or inconsistent. Or sometimes they may ask you that what type of graphical solution we will get, or what type of algebraic interpretation will be there for the pair of linear equations in two variable. So that very easily the consistency of these equations we can check. So what we have to check here, so that one table is there. Here I have written some headings. If you see here, the we'll compare the ratios. Here the graphical representation, what type of solution you are going to get. So in advance, before solving it, first you will check it, and very easily you will get that what type of solution you are going to get. Then algebraic interpretation, what it will be there, that what type of solution, if you are solving not graphically, you are solving algebraically, whether the substitution method you are using or the elimination method you are using, then what type of solution you will get. And when you will get the solution, so as per that you can say that yes, the pair of linear equation is consistent or inconsistent. Consistent means if the solution you will find out, you will get the solution, that is means they are consistent. And when there is no solution, so then we can say they are inconsistent. So what we are going to check from this, so a1 by a2, the ratios we are going to check. What ratios we are going to check? a1 by a2, b1 by b2, and c1 by c2. Already the meaning I have explained you. So these ratios of a1 by a2, b1 by b2 and c1 by c2 will tell us in advance, before solving the equation only, that what type of solution we are going to get. Okay, so first of all, if we will get the ratios a1 by a2, if we'll get not equals to b1 by b2, this is the first condition. You can say that if a1 by a2, if it is not equals to b1 by b2, then the graphical representation of that, what you will get? Intersecting lines. Intersecting lines. So the lines, both the equations which you will represent on the graph, the graphical representation will intersect, will cut each other at one point, you can say. If I'll draw here the two lines on the graph, we will, when we will learn this graphical method tomorrow, then it will be more clear to you, right? Then what is the algebraic interpretation for this in graphical? So very easily we can tell that if a1 by a2 only, so no need to check c1 by c2, then only by these two, first two, a1 by a2 and b1 by b2, the coefficients, numerical coefficients of x and y will tell you whether the you will get a solution or not. So if they are not equal, so no need to check then c1 by c2. So in algebraic interpretation, what you will get? Unique solution. Unique solution. A unique solution you are going to get for in algebra if you are solving it. So value of x and y, very easily you will get it if a1 by a2 is not equals to b1 by b2. So because we are getting a solution, so we can say it is consistent. Consistent. So the pair of linear equation, if you have to find, so all at one place I am giving you, that whether you have to check in MCQ that whether they are consistent or not, so that you can check by this. In the algebraic expression, if you are to solve by algebraical method, either that substitution or the elimination, then before solving it, first you check it whether the solution is there or not. Many times the question I have seen in the board, they ask where there is no solution, and students, without checking this, the consistency, they start solving it by the method, whatever the method they have asked, or by elimination method, and in the end they are not getting the solution. They are trying and wasting their time, because when in the beginning only you will check it by this consistency and there is no solution, so why to waste the time? Directly you can write, because a1 by a2 is the condition when we will write for no solution. If that is fulfilled, so directly you can say there is no solution. Okay, so this is the first condition. The second condition is that if a1 by a2 is equals to b1 by b2 is equals to c1 by c2. After explaining these all three cases, then some examples we will take one by one for all three cases, then it will be more clear to you. So don't worry. So what is a1 by a2, b1 by b2 and c1 by c2? If all these three ratios will be equal, so what we are going to get in graphical representation? Coincident lines. Coincident lines. Coincident lines means both the lines will coincide with each other, means they will overlap. One line and on the other line also will be on the same line. So that means that every point here, so a unique solution is there, they are intersecting, because two lines whenever they intersect at one and only one point. So a unique solution you get algebraically, and intersecting lines where both the lines are intersecting, you will get the solution of that pair of linear equations. But when all three will be equal, this possibility is there only when a1 by a2 is not equals to b1 by b2. Then intersecting lines and unique solution, so they are consistent. Second case, if all three are equal, all three ratios will be equal, then the graphical representation is coincident lines, means both the lines will be the coincide with each other. So every point is the solution. Every point on the line will be the solution. So we can say that what algebraical interpretation then? Infinitely many solutions. Infinitely many solutions. Then infinitely many solutions will be there. So again, because we are getting the solution, so the pair of linear equation, whatever is given to you, is consistent. So again, all three things we have checked. In these three, in one chart only, you are learning that when they will be in algebraic, you will get coincident lines, infinitely many solutions. So solution you are getting, so consistent. Now the third case, third possibility is that a1 by a2 so is equals to b1 by b2 but not equals to c1 by c2. So these two ratios so will be equal like here, but here that c1 by c2 is also having the same ratios, the constants also, but here this will not be equal. C1 by C2 ratio will not be equals to the ratios of these two. So then in graphical representation, what sort of lines you will get? The parallel lines. Both the lines will be parallel to each other. Parallel to each other means they will never cut each other. And when they will never cut each other, so that means there will be no solution. So in algebraic interpretation, what we can say? No solution. No solution. And no solution is there, that's why it is inconsistent. When solution is not there, so inconsistent. Clear? So consistent only when the solution is there. Solution is there only in two cases. How will you check it? If the ratios of a1 by a2 is not equals to b1 by b2, so graphically method if we'll solve, so we will get intersecting lines. By algebraic method if we'll solve, so what is algebraic interpretation? A unique solution you will get. So we can say solution we are getting, so they are consistent. If all three ratios are equal, so graphical method, what we will get? The coincident lines. Here infinitely many solutions, because both the lines are coincide with each other, so every point is the solution. So line has, there is no end of a line, so infinitely many solutions. And here the consistency, if you have to check, so they are consistent because we are getting the solution. Then for a1 by a2 is equals to b1 by b2 but not equals to c1 by c2, then the lines will be the parallel lines. So we can say that is no solution algebraically, and the lines are inconsistent, you can say. So these are the three, you can say, that the interpretations we can say algebraically also, or I will segregate this, otherwise it will be mixing all. Right? So I hope that these three conditions are clear to you, that if consistency we have to check, so just by this directly we can say they are inconsistent or consistent using these ratios. If we have to check algebraically what sort of or what type of solution you are going to get, then also we will check these three conditions. Or if graphically we have to check, then also these three conditions. And now one by one different examples I will take, and we will check that how we are going to get in different questions, because here so